All right. We are going to get started here. So, welcome everyone that's listening live. And for those of you that are watching this later, welcome to Revolutionizing Manufacturing, the Power of AI Automated Downtime Labeling. So, this is a webinar about addressing micro downtimes and scaling expertise in manufacturing. Just a quick note on the challenge in manufacturing today. There's tons of factories in the world, around 10 million, and there's extensive money spent on software today, but nothing compared to what's spent on labor, $4 trillion to do work. And to do work, you need experience, generally 5 to 10 plus years to do really good work in a lot of factories, especially advanced factories. Head of TSMC quoted as saying they needed really 10 plus years in their semi-fab factories, and it goes down from there, but still many years, even in most factories. About 10 years ago, in most countries around the world, the average tenure was 15 plus years in factories. And so this wasn't a problem. It took a lot of time to train people and get them up to speed on the ever-increasing complexity of the machines, but this was a tractable problem. Now, in many factories around the world, the average tenure is as low as 5 years and dropping. So there's a $300 billion expert labor crisis that's rapidly growing. How do we run our factories extremely well with the people we have? In other words, we have to do more with less. A quote here from Paul Baldessari, who leads global operations at a large contract manufacturer called Flex, over 100,000 operators reporting to him. Paul says, each year we have to do roughly 10% more, but we have to do it with the same number of people. So in this webinar, we're talking about micro downtimes and the growing skills gap because these directly play a role together. So in factories around the world, sometimes we focus on the large downtimes when a line goes down for, say, 2 days at a time and just everything is going off screaming. But another giant challenge is the small downtimes, like the graph shows here up at the top, the unplanned downtimes that happen in 1 minute, 5 minute, 1 hour increments and add up through every single day, often contributing to losses in the hundreds of thousands to millions over the year for a plant across many lines and machines, kind of death by 1,000 cuts. The experts are needed to deal with these too. Just because they're small downtimes doesn't mean they're easy to understand or easy to solve. They can be just as hard to understand and solve as the big long ones, but experts are needed elsewhere for like the most critical problem at a given time. So that means you typically can't allocate your experts to it, but traditional downtime requires experienced people to understand it. The labor shortage is widening the gap, retaining, hiring, and motivating qualified individuals to do these manual repetitive tasks of labeling all these little downtimes and then understanding later, is the same thing hitting us every single day? So we can make a change in our practice to how we're managing materials, a change in our practice to our schedule, etc. The ripple effects are significant. So manually labeling, first off, often is not getting done, but when it is, it's prone to error. It's time consuming, and it's often inaccurate. Sometimes operators will just click the first one just to get it over with. Other times they're legitimately trying, but they don't know the right one to pick, and they didn't have enough time to figure it out. Busy operators have to choose their battles, right? Skilled workers are going from machine to machine, prioritizing the investigation that matters the most. And at the end of the day, small downtimes are ignored in most factories around the world. And again, this amounts to millions of dollars of loss per year across sometimes single plants and definitely multiple factories. And this is a job that your team doesn't want to do and no longer has to. That's what today's about. It's about this new concept of AI automated downtime labeling. The idea that AI can eliminate the need for manual labeling by automating this process entirely. Not just, a quarter or a half as was sometimes done in the past, but entirely. The key principle of this is being able to take what we call the voice of the process and the voice of the operator, combine them into something that this AI can read or look at and pick from the reasons. And we're going to jump right into some demos to make this understandable of what does it mean to give voice to a process and voice to an operator. But I think we can all appreciate if this is possible, it removes this dependency on experienced personnel to constantly be in the weeds of this, and they can finally focus on higher value work, like later reviewing all these well-labeled downtimes and making a strategic change, or like helping the biggest problem in real time. So let's now go straight into a demo on AI decision making, how we go from factory input to AI-driven decision. Joe, can I hand to you?
Yeah, please. Okay. So if I can take the share here.
Go ahead.
Okay, so I'm just going to pull up our tool React. React is what we use for downtime monitoring. So here I'm navigated to a line. This is a SMT line, right? And this is the interface that a line operator would see. You can see it's flashing red, so I know that there's a downtime happening. The system is telling me something is going on. And already right away, this is the difference in our system. A lot of systems would require the operator to see that downtime is happening and then go in and manually report that it's going on. We monitor the line for downtimes automatically, so the operator is notified whenever it's happening, and they can come in here. And the next step, once you see that downtime is happening, with most downtime tools, the operator is asked to label it in some way. And that's a very manual process, as Andrew was talking about. So we have that tool as well. We allow operators always to manually label if that's something that they need to do to override the system. But the features we've been building and what we're excited about is AI features that automate this entire process. So you can see I have a live downtime that's happening, but there's also some past downtimes here. And I've intentionally left them unlabeled. But what the system does is if you look at the bottom here, it says insights. The system will give you suggestions on not only the label, so the category and reason for what a downtime might be, but also the machine that is to blame for that downtime. So we've set the system up. You can do a couple different ways. You can have it automatically label for you just with whatever suggestion our agent gives to you. That's more of a co-pilot mode. Or we have it set up so that the operator would review and apply. And then it's as simple as just applying the insight. And you can see that downtime now becomes labeled, right? So you go from having an insight, clicking in, and then just applying. Above here, I have another
So Joe,
downtime.
the system
Yeah,
behind the
please.
scene grabbed information from the voice of the machine, and I think you're going to tell us more like what that meant. But it had
Yep,
somehow already figured out exactly which machine was responsible, and then even it was the feeder, and then
yep,
you just clicked apply without having to do that investigation.
exactly. Just clicked apply. Similar here, I have an insight. This completely different. Before is telling me a machine error. Here, the system is telling me looks like there is a break, right? So the question then becomes, how does this all happen in the background? And just as Andrew was talking about, we take what we call the voice of the operator and the voice of the process. We combine these together into a synthesized document. This is a payload that we feed to the LLM to ask it to analyze and then return its best guess at a category and reason and machine. So we take the voice of the operator, context that the operator can gather in situ while they're examining and monitoring the line themselves. And they can do this simply by either typing into the system, or we have voice capture and voice transcription. So any language, anywhere, transcribed, used by the system to categorize, and voice of the process. So all of the machine data, all of the line data, everything that's happening across your line at any time is also used combined with that context from the operator to create this document. We then put that together and give it a prompt. I won't show you a full prompt. I will show you some pieces of a prompt, and we've redacted some things, and then I'll show you a bit of the payload, the synthesized document that we use. So a prompt would look something like this. This is obviously for an SMT line. So we would prompt LLM to say, act as an SMT line operator with deep knowledge of the manufacturing process. We'd say, you're about to be given a synthesized document. It contains a lot of relevant information. There's some things like the factory schedule, source data, so event timing, machine of blame. This is machine state data. This is an algorithm that we at Arch have developed, more of a data science algorithm. There's metrics of like UPH, takt times, things like that. And then there's operator comments left by the operator that was working on the line at the time of the downtime. We tell it what to pay special attention to. We structure in a way that the LLM can make sense of that payload. We're not just dropping it in and then saying, hey, tell me what to do. And then we also ask it to give us a structured response, so a category and reason based off of the schema that we feed it. So this is part of the payload that we give. But what really looks like in the background is we're giving it this kind of called a blob of code that has everything from very specific downtime information about what we call a job, or some people call a work order, where the line is, the shift information, what job is running on each machine, the takt times, the thresholds for downtimes, things like the factory schedule, as I mentioned. So exactly what shifts should be working, when a meal or break might take place. And this is something that we have features to store in our system. We can also ingest this from other system, like an ERP. Then we give it the schema or the setup for categories and reasons, right? Here we have, this is the results of a machine of blame algorithm that is run. So we're looking at the insights for that first downtime, which is here, these insights here. And so, then we also put our prompt in here. And the result is we get a category and a reason. We get the alarm, we get the machine. And these are all things that we can then use to label and classify that downtime. So
yeah, so you
going
have to
back,
you
yeah,
talk to these AIs like a human kind of and a machine at the same time. So you showed how kind of like if anyone's used ChatGPT, you prompt it like you're an expert operator. This is the task I'm going to give you, and then but in real time, we are supplying these payloads of well-structured data about the machines and even the results of data science to then cause it to pick and return its response in a way that the software can automatically label. Is that a good summary?
exactly. Yeah, exactly. And we're speaking to it directly via API. So all of it is done in code and then received in code and then pushed back into our interface. But we're speaking to it like it was the operator. That's how it operates best, in a natural language. And then again here, we have the insights here. It decided it was a man category, reason break. Let's look at that payload. If we look at the factory schedule, we have the timings here for the meal. We have the timings for break, the different shifts. We look down at, let's see, there's no operator comments. There's no machine of blame. Adjacent machines were running upstream and downstream. So it took from the factory schedule and said, looks at the timing. I don't see a machine of blame. All the metrics look okay. All the machine states look okay. This was a break. I can tell by looking at your schedule that you had something already prepared. So gives it the category and reason right there.
Yeah. And do process of elimination too. Like sometimes there's just
Exactly.
an explicit machine error, but in this case, everything looks good, but the time and the schedule are off. It's got to be that one.
Exactly. And then you can just apply, your insight gets applied, and there you go. So you have the difference between an unplanned and a planned downtime, all being automatically categorized by the system.
Very nice.
Yeah. So those are instances where we have a lot of information, where we have, either schedule information can tell us, machine of blame, our algorithm can tell us, and kind of start to shape and form what the LLM might say. But there's also instances where you might not have that, right? You might only have contextual information. So here I have a live downtime happening. What I can do, and what we encourage users to do, is, especially if they're using mobile devices like tablets on the line, or they have access to the interface on the line, is to add context that they can, even if it's a short blurb, whenever they can, add context for the system. So here I can come in, I'll add a quick comment, and we'll see what kind of insight we get back. Saw smoke coming from the oven. Very quick. I'll submit that. We'll give it a moment to transcribe here. Once the system transcribes, puts it into text format, adds it to that payload, which is then sent to the LLM, added into the prompt that we give it, and it responds back. So here, transcribe, saw smoke coming from the oven. I'll close. Let's look at our insight. And there, just from that, it can derive, looks like it's probably a reflow issue on the machine, somewhere on a machine, probably the oven, and you have a
Yeah,
label that you can
for
just come in and
those
apply.
for those familiar with SMT, that one maybe jumped out, and for those not, in the circuit board process, there is an oven which does solder reflow. And so you could have said that in any language, Spanish, Chinese, English. You just said smoke from an oven, and it was able to connect oven to the reason happened to be called reflow. It wasn't even the same word, oven, but it was able
Yep,
to reason that you said oven and smoke. Of all the reasons, that must be a reflow issue, right? So that was pretty cool too.
exactly. Yeah. Oven, smoke, I'm an SMT operator, must be.
So it can look through our detailed machine data and models, and it can learn from a sophisticated data science we've done. It can do process of elimination. It can see that there's no issues in the data, and therefore, oh, but there is something off with the schedule. And then it can also do reasoning of words in different languages to the reasons to understand, okay, it has to be this one because I know what you meant.
Yeah, exactly. Of
Very powerful.
Yeah,
Fantastic. Thank you, Joe.
course.
So let's come back here to the discussion and welcome folks. If you have a question, to go ahead and start thinking about what you'd like to ask. We wanted to leave a little bit of time here to do that. But as we kind of wrap up, let's put on a slide some of the key principles here that you just saw live. So what's again happening? How is this? Like this is brand new. Almost every MES, every SCADA, almost every machine in the world has some kind of very basic downtime labeling system. There is no system in the world yet, besides ours, that we're aware of, and maybe there'll be others soon. And last year, ours included, there was no system in the entire world that could do what you just saw, which was automatically label downtimes based on AI reasoning. So again, what's happening here? Well, first, it starts with some understanding of the factory, right? When did you even flash red? And you saw Joe demonstrate that. AI has to know when to kind of wake up and try to do this reasoning. So there's some kind of trigger. And in this case, Joe showed how in some models, you have to click and tell it there's a downtime. But no, this knows there's a line, that there's a job running, that if you haven't seen a board for 20 seconds, there's a downtime right now. That wakes up this AI decision agent who now is going to leverage this digital twin of information to get whatever it can to solve the problem. So you saw Joe gave an example where there was some really interesting machine data, a complex algorithm we built called machine of blame. It knew the exact module of a robot that was causing it, and it had an error code, right? You saw another example where it could have had the voice of the process, voice and eyes of the operator, an operator comment, but it was all empty. And the machine of blame was empty. There's no machine to blame. So it was just the schedule. Because the schedule was answered, it could use process of elimination. And you saw the third example where there was no information except a very brief operator comment. And so the more information that's put into this synthesized document, the more likely the AI is to always get it right. And beyond even picking the root cause, it's probably this, even be able to say things like, and this is how you solve it, and this is my guidance for you. And so again, you saw a different collection of these inputs that the AI could access from this linked digital twin, pulling it into the document, asking the AI to make the decision, return its decision, so the software auto labels, and then the operator confirming, and also being able to add more knowledge as they go. Now, this is having real results that matter. People that are close to this probably get this inherently. Like that saves labor, that actually allows you to label downtimes. And what happens if you actually have labeled downtimes? Well, you identify problems that are really significant that you can solve. This is an example of a factory that we were working in. The system was deployed. And in fact, our own system, kind of being modest, was deployed in this factory towards the beginning of this graph with KPIs. And so there had already been, I would like to say, some good improvement from the non-AI version, but nonetheless, there was still downtimes here of 5 to 7 hours happening on an average kind of line per week here. And as we implemented better ability to label downtimes, and with the people they already had, back to the quote of people like Paul Baldessari, I got to do 10% more with the same people. They were suddenly able to label and understand things better. And you can see this massive additional drop in downtimes compared to what they had before, down to about an hour, which in this particular site was worth over $2.5 million, a really outstanding result that they were able to achieve with this. So, okay, what's next for AI in manufacturing? General auto root causing. So what you just saw was, again, an AI reasoning from a set of different inputs to pick from a set of standard downtime reasons. Maybe your organization has 5 or 10 or 100, and it can pick between them. But as you saw, the power of what it can do is not limited to just kind of answering a multiple choice question. And we're going to be able to start sharing how this breakthrough goes beyond this, right? It can say what you should do about the downtime. It can also root cause not just downtimes, but performance slowdown issues. It can root cause quality issues and scheduling issues. It's really a very powerful and flexible tool. Also, generative AI is allowing us to accelerate the ability to use these broader data sets, right? Integrate more sets of data faster, use them in new ways, just a voice comment, even looking at a dashboard, allowing the AI to look directly. And all of this too makes it easier to adopt and use when operators in different countries can talk in their own language, put in the comments the way that's comfortable to them, take a picture or not take a picture. You can connect machines or not connect machines. And you don't need the entirety of the data set in every factory for these to work. You can start with the ones that are accessible to your team and then have an interface that, again, speaks in a way you're familiar with. So these are all things that we're really excited about and we're going to be talking about more. So if there's any questions, we could field those for just a few minutes, but that's the end of the official webinar here, and we're really excited to continue the conversation. So I'll pause, and you're welcome. Those that are live here, welcome to go into the chat and add any questions that they would like. All right, so we do have a couple. One question was, for what types of brands of machines could this be used? This person shares that most of our issues is missing parts on the S&T line, lack of materials. Okay, actually, I've got something cool for this one. So I just happen to have ready a video here of a line. So take a look at this. This is the type of data that then can be fed into these AIs again. And if you look, okay, here's a line, and it's showing live green, yellow, red. There's a red, number 10. This is a circuit board line. There's a yellow status on the printer. There's a red status on machine 10. And I know there's a big table here. Would take us all a little while. What exactly are we looking at? AI gets to look at it right away. If you look machine alarm, it's the kind of 1, 2, 3, 4, 5, 6, 7. There's something called wait parts down there. In the data right now, machine 10 is red, live. This is like live, an example of live data streaming from a factory, and there's a wait parts error exactly on that. So this was not a coincidence. I didn't know you were going to ask that question. I happened to be looking at this anonymized screen just earlier, which is exactly showing a live wait parts error that now you saw it made the next machine go yellow, and now that machine is, and it's going to kind of bounce around the line. This is an example of the kind of live data that AI can look at and say what downtime is happening. It's like, okay, it's wait parts. It's like literally spelled out directly. So some of these are very explicit, the AI, and some of them are less. So that was one part of your question. Can it do lack of materials? Absolutely. And then your other question was, what types of brands could this be used for? Well, this is something that's really exciting because in the past, it was more limited. And if you asked us even 6 months ago, where we were first rolling this out, Arch specifically, what kind of brands does this work with? We would say it works with Fuji, works with ASM, and it's starting to work with Panasonic, and we have others on the roadmap. But we also just launched something fantastic as this is accelerating. There's, in the voice of the process here, you see operator dashboards. We have an accelerated ability not only to kind of pull raw data and model it in a really sophisticated way, but again, as Joe showed, to just let that operator talk. That is completely unlimited to what machine you have. Anyone can talk about anything. And also now to let the AI take literal screenshots, take pictures of the dashboards of the machines. Any machine that you have in your factories where you can access a link of a dashboard, we can grab that into the AI immediately as well. And so if the root cause of your problem exists on any dashboard, we can actually pull these into this AI right now. If it could only exist if Arch would build a new model or whoever you're working with, then the timeline would be for that model. And happy to take that one offline, what our roadmap is to build successive advanced models for different machines. Any other questions? So maybe one more here I got from the side. Somebody else asked, is that they were asking about the first example, Joe, that you showed, and they were asking like, is that a machine learning model that you're doing? And this is a really common one that we're getting right now because this is actually combining AIs, so to speak, because we've been using the word AI in this industry for 10 years. And in the past, when we said AI, we meant something like a machine learning model where you had tons and tons of data and you would let it pattern match. And we are actually doing that. I think the first example you showed, Joe, machine of blame, is a tons and tons of data pattern matching which machine is causing this. But overall, the decision agent here is not a machine learning. It is a generative AI like ChatGPT, like the new kinds of AI that maybe some of you are using in a commercial way. And I just thought before we'd run out of time, because that's such a common question and a good one, I also really like to just get an intuitive sense of how these things work. It makes it more natural and understanding. So let me give you an example here. Instead of asking why the factory line's down, is it materials or man or environment? How about we're going to ask AI, what am I drinking this morning in my cup? And if you're watching this webinar, you can see my cup. You see some clues here, and you probably already have a good idea. But first, let me give AI not a picture, just a little bit of a hint here. So. Okay, AI, your job is to guess what's in my cup. It could be beer, liquor, orange juice, or those are your choices right now. And I'm going to give you just the data that it is 1:30 p.m. Eastern time, but I'm in California. What would you pick? Always got to love your live AI demo here, right? Let's try it once more. All right, AI, can you hear me? Wow, OpenAI is actually lagging right now.
I'm here to help. If there's anything else you need, just let me know.
It has awoken. All right, are you ready to answer a question?
Absolutely. Go ahead and ask your question.
Okay, I'm holding a cup, and you need to guess if I'm drinking wine, liquor, or tea. Your clue is that it's 1:30 p.m. Eastern time, but I'm in California.
Since it's morning in California, tea would be a more common choice. So I'd guess tea. Is that right?
You got it. Okay, now I have a different cup in my hand, and
Sure. Feel free to let me know the options or details, and I'll do my best to guess.
so I'm not even going to give you the options. There are thousands of beverages in this home that I'm in, and so it could literally be anything, but I'm going to give you a richer data set. I'm going to turn on the video right now, and I'm going to let you see this cup in my hand. What am I drinking?
Based on the video, it looks like you're holding a blue ceramic mug with a tea bag label visible. So it appears you're drinking tea. Is that correct?
You got it. So intuitively, I gave AI some time series data, the time and my location, and because it had a restrained set of choices, luckily it did not think I was drinking alcohol in the morning, and it was able to translate time zones and guess, tea or orange juice, whatever was the most logical choice. And then when I gave it no choice whatsoever but a picture, it was able to get a lot. So in the same way, this generative AI, on top of this data that we have, even with a small data set, but a limited set of your downtime reasons, can almost always pick accurately. But as you build a richer set, it can not just pick a downtime reason, but give you a detailed understanding of what's going on. So we're going to end there. Everybody have a great rest of your day. Thank you for joining. And everyone that's listening to this later, we appreciate your time. And I will just throw up our closing slide one more time here as we send you off. So thank you again. And this is an ongoing conversation. We look forward to chatting about more. Take care.